So now here's an example. My new friend Michael from SLI this summer is pushing a cart up a ramp that is 5.0 meters long. What is the IMA of the ramp if the platform is 1.5 meters high? So as I showed you before, the length of this slope or ramp is going to be my distance effort. So I've put 5 meters here. And my distance of my resistance is going to be the height of this ramp, or basically the height, the distance that it traveled from the ground to the top of the platform, which is 1.5 meters high. So I plug that into my calculator, 5.0 divided by 1.5, and I get 3.3. So my IMA, or ideal mechanical advantage, would be 3.3. In the second part of this example, we're going to find the AMA and the percent efficiency. So the ramp is inclined at 26 degrees. Michael pushes the 350 Newton cart with a force of 180 newtons up the ramp. What is the efficiency of the ramp? Well, I'm going to be using this equation here. Percent efficiency equals AMA divided by IMA times 100. I've already got IMA from the slide before, and I found it was approximately 3.3. Now to finish this equation, I also have to know AMA. So AMA is always force resistance over force effort. Up here in the example it says the cart is 350 newtons. So my force resistance is going to be 350 newtons. Now Michael, with his big strong muscles, is pushing this cart with a force of 180 newtons. So that means his effort force is 180 newtons. I plunge this into my calculator and I find that it's approximately 1.9. So my IMA is 3.3, my AMA is 1.9. Now remember, IMA is ideal. It's the ideal mechanical advantage, assuming that there is no friction, right? No outside forces. So we are expecting AMA to be lower. Right? So now how efficient though is this system? So percent efficiency is going to be AMA, which is approximately 1.9, divided by IMA, which was approximately 3.3. I multiply that by 100, and I'm going to get 58%. So the efficiency of this ramp is 58%. Now let's take a look at what I found there in the garage, or actually it's a trailer, the ramp on the trailer to get up to the platform. Here's an example of an inclined plane. Whenever you're trying to move something from the ground up to, say, a trailer like this, it's easier if you're going to lengthen that distance and going up the inclined plane instead of just lifting it this short distance to the bed of the truck or on a trailer like this. So what we're going to need here to find that ideal mechanical advantage is we're going to need to know the distance that it's going to travel, whatever it is that we're moving. We're going to need to find this distance, the length of my inclined plane. And then we need to know how far did the resistance really travel up. So we're going to look at from the ground to the top. And that's considered our distance of our resistance. Distance of my effort is how far I actually pushed it. Alright, so we're going to look at the length first. I'm going to take the tape measure, put it down to about where the ground is. And see that here, to come a little bit closer, is 52 inches. And that's the length that it's going to travel. Now, the height of the inclined plane is what we're calling our distance of a resistance. And the height to where I measured is about to that mark right there. And it is 19 3/16 of an inch. 19 3/16 of an inch. And that's what we're calling our distance of our resistance. Now I'm going to use those measurements that I just took of the ramp going up to the trailer. So I'm going to use this equation right here because I have distances, and so I'm going to be able to find my IMA. All right, so IMA equals distance effort over my distance resistance. The length of that ramp I measured to be 52 inches, and the height going up to the trailer from the ground was 19 13/16 of an inch. I'm going to simplify it a little bit more before I plug it into my calculator. Again, I know that inches are going to cancel out. And say 52 divided by 19.8125. I think it's easier to do the 13 divided by 16 to get my decimal and then plug it all in like that. Okay, so 52 divided by 19.8125 is 2.6. Or if I want to refer to this in ratio form, it would be 2.6 to 1 is my mechanical advantage. This means that it will take me 2.6 times less force to put the object on the trailer bed than if I lifted it straight up from the ground. Hopefully this helps you in understanding the mechanical advantage of an inclined plane.